podcast. Welcome to my channel 5 Minutes of AI. And today we will be discussing part 2 of this medical intelligent data processing series. But before that, I would like to say uh, complete the part 1 video because it contains the theory what we will be doing in the part 2. So if you miss part 1, you won't be able to understand part 2 because you will be confused what we are doing in the part 2 of the video. So please complete the part 1 of this series, then only come to the part 2. So in these all things I've already discussed in the part 1. If you want to go, you can go through it. I've kept in the collab. So database, what database I'm using? I'm using ICD 10 CM codes 2024 and I've downloaded it from CMS website. And then I've segregated the text into two columns. First is ICD code and other is ICD description. So there are 74,000 plus ICD codes and its respective description. So after feature engineering, I have installed sentence transformer and stanza model and then loading all mini LM L6v2 model in the sentence transformer so that I can find the similarity. And you can also, if you want to know more, so I have provided the characteristics for that model. You can go through it. The first thing which we did is finding the embeddings for all the ICD code descriptions. So we are finding embedding for all the 74,000 ICD code descriptions. So why we are finding it? So that we can find the similarity score with the stanza output. And since it is very time consuming when we are encoding those and finding the embeddings for all these 74,000 ICD code description, so I dump it in the local and then I load it from the local. So if you want, you can do it that way also. So in this stanza, we are downloading and initializing its pipeline with the I2B2 NER model. So medical reports generally have diagnosis sections. So where it is mentioned like what patient is suffering through or problems patient is going through. So over here I have created some dummy problems for a patient. So he's suffering from chronic kidney and all. And when I provide this text to stanza I2B2, so it will extract all those problems and from this text. So you can see these are the three problems which stanza was able to find it, and I have stored it in a list. And after that, what I will do, I will encode this and find its embedding. So there will be embedding for this chronic kidney disease, diabetes, and HIV. So now coming to this step, I am finding the similarity between all these NER against the 74,000 ICD code description. So what actually I'm doing, I'm taking this chronic kidney and I'm matching that which description matches with this chronic kidney or which is most similar to this chronic kidney. Same with diabetes and same with HIV. So after this, I will be getting a score matrix. So I'm sorting that matrix on the index which contains the maximum similar score, and using that index, I will find the what do you call it which ICD code is on that index along with ICD description on that index. So uh, you can see over here chronic kidney description chronic kidney disease unspecified is matched with a score of 88%, 88.51 from the database, and the ICD code for that for this description is N189. So similarly for diabetes, diabetes mellitus due to underlying condition without complication is matched with a score of 73.68, but just diabetes NER. So this is what we we will be getting as a result. So before you skip my video, please listen carefully. This is not the complete project which we have delivered to the client. It is almost 40 to 40% of the project which we have delivered to the client. But this is almost complete project and it is potent. So you can put it in your resume. And medical intelligent data processing is very hot topic right now. So in mediclaim and all is very manual driven, sector. So every company wants to automate this thing, like what we are doing for ICD code. So they want it to for medication, CPT codes, and then patient demographics and whatnot. Like the immense opportunity in this. So they want to automate entire thing. So since Mediclaim documents are huge, so I have saw a document of 13,000 pages something. So it take like days and days for a worker to work manually and such codes and other things from that document. And but client wants it to process it in under 5 to 10 minutes of time. So that's what they are approaching to us, and so we have delivered a model successfully. And this is the thing which you taught right now is part of that model. So yeah, you should be sure that this is industry project, not any Kaggle project or something, and you won't find it in the Kaggle also. So that's all from my side. Please like my video, subscribe to my channel, and press the bell icon because I will be uploading amazing projects very soon. Thank you.